Aloha, how's everyone doing today? My name is Jim, going to be your presenter today. We're going to talk about the OWASP Top 10. Look, I got some things to do. I'm a little bit busy right now, but we do need to talk about the OWASP Top 10. It's going to benefit you professionally. It's going to benefit you intellectually. It's something that we all need to know about. So I'm going to talk about it, even though I got a few things to do. We're going to do it We're going to do this efficiently. We're going to do it efficiently. Let's do this. So I'm going to share out my lovely screen here. Let's get this party started. All right. Yeah, the OWASP Top 10. Hi, everybody. It's game time. OWASP Top 10 and more. Who the heck am I? My name is Jim Manico. I'm going to be a presenter from Hawaii. Wrote a book on secure coding. Been a programmer most of my adult life. We want to develop secure code. I recommend to develop a secure code, you abide by a standard. The application security verification standard is a standard from OWASP specific to web and API security. We have the OWASP cheat sheet series. It's a living encyclopedia of secure coding knowledge. The point is we want to be informed about what security is from an engineering point of view before we write code. Pretty basic. And the other big point of application security is testing. These days, we want to use automation to test our software for security on a continuous, cyclic basis, usually using at least 3 tools: static analysis, dynamic analysis, and software composition analysis. 3 tools automated every day testing for security. It's DevOps, the security aspect of DevOps. Also, automation only covers so much. Be sure that you have penetration testing with an expert testing your system for security issues that automation doesn't do a great job at, like access control or business logic or similar. The OWASP Top 10 is an awareness list. It's not a standard. It's just meant to provide education like we're doing right now. These are the OWASP Top 10 items: injection, authentication issues, data protection, XML issues like XXE, access control, configuration for security, user interface security, cross-site scripting, insecure deserialization server-side endpoints, and command injection endpoint, using third-party libraries, which could be any other bug on this list, and more. And then A10, insufficient logging. These are you know what, this list is a little clunky. It's not perfect, but it facilitates a conversation like this. And this list was first built in 2018. These categories were new in this version of the OWASP Top 10, and we're getting ready for another Top 10 in 2021, so this list will be refreshed in the next year. Let's start with injection. I worry about SQL injection. SQL injection happens when the attacker can add his or her own SQL into your application by different input fields. This has been a #1 risk since 1998. Jeff Forrestal, Usenix meeting, Christmas Day, coined the phrase SQL injection and began this era of attacks. And this is what the problem is from a code point of view: string building with SQL creation. It's that dynamic SQL we want to stop. And by the way, validation's not going to save you. This is a valid email address. It's live and valid. And yet it will cause SQL injection. This is the universal truth attack, or 1 does not equal manicode.com with a legal email address. So go ahead and do good validation, but you have to parameterize your queries. You also want to configure your database properly as well. That's the goal of stopping SQL injections. 3 defenses. So parameterized queries exist in Perl even. We have placeholders. Notice there's no string building. We're binding data into the query. It exists in Java prepared state. It's in .NET. At the bottom, there's the Java prepared. There's a .NET prepared statement in C#. We have even object databases like Hadoop. There's an HQL statement on the bottom with a parameterized query. And be careful, some parameters can't be parameterized. Use strict exact match validation when you can't parameterize. Escaping's not going to help you. And be careful. Learn to parameterize your queries. Take this seriously. Bobby Tables will show you parameterized queries in many languages. So will the cheat sheet. It's a requirement in ASVS. We're now looking at 2. Broken authentication. A2 OWASP Top 10. What's authentication? We're verifying who the user is. A session can be stateless like a JOT or stateful like a traditional session. What's changed a lot in this world is password policy. #1, don't limit the password strength. and use a modern password policy scheme. And what does that mean to us in the US, right? It means stopping things like credential stuffing. By when a user registers an account or changes a password, make sure that username password combination is not known from a public breach. And look, I know you probably don't want to blindly follow US regulations, but hang on, some of you code for US companies, and this is smart stuff, even if you don't follow it. It's just good research. This is NIST Special Publication 863. It's the US government digital media guidelines for passwords. Don't limit the characters of a password, at least 8-character passwords, and use multi-factor for sensitive data. 8-character passwords with MFA is legit. Block context-specific passwords like the word password or username or the name of your company or name of your industry. Block the top 50 to 150,000 common passwords. Stop credential stuffing by checking against the list of breached username password pairs. Throttle brute force attacks. Drop all these garbage special character rules. Don't use password security questions or hints. We can look them up. No more password expiration for the sake of it. It does bad patterns. And again, any printable character, and again, multi-factor as soon as sensitive data is in play. And now we have a very different kind of password policy that meets up to how we're actually attacked. This is a bad password. It's a common pattern. The word password's in it. It's one of the most common passwords for enterprise password policy. I don't like it. So we also want to store the password securely. A lot of devs will store their password insecurely. We care about password storage after your database has been breached. The attacker can throw supercomputing power at it, like all of these breaches show us passwords in the wild. So we have to defend against that as well. Remember that. And by the way, this is scrypt is an example of a good algorithm from just a couple of years ago for password storage. We have internet-based cloud cracking services. But the key is to pre-hash, use a good algorithm, and then encrypt or MAC at the end. Number one, make sure you hash the password before you store it. Number two, make sure you use the right algorithm, bcrypt, scrypt, or Argon2i. Number three, after you protect it with the proper algorithm, and by the way, hash cracking is that fast, MD5, 200 million attempts per second on my laptop after I stole your database. Take a breath. SHA 68 million on my laptop in terms of password compares per second, and bcrypt only 390. It actually helps. Java bcrypt, there we go. At least a 13 work factor in my opinion. It's in bcrypt, it's in PHP. Scrypt is a good algorithm. I'd use Argon2i these days. You know, scrypt is cool if you have it already, but really if I was going to pick an algorithm, I'd go bcrypt or I'd go Argon2. When I'm done with bcrypt or Argon2i, I then recommend you encrypt at the end if you have a good key infrastructure in place, and then protect the password. Now we're talking modern password policy. And by the way, when we look at the same NIST standard, we look at this workflow and these different guides that say, the only point of these slides is in the standard that says, if you have sensitive data, then you immediately need to do at least AAL level 2, which is multi-factor. So, you know, if you have a sensitive system without multi-factor of some kind, it's like, welcome to 2020, folks. It's basics. Next, sensitive data exposure, right? We want to make sure that we have well-configured HTTPS anywhere. Anybody have a good excuse to use HTTP? Go ahead and say it now. It's wrong. I'm sorry. I apologize. Use HTTPS everywhere. Hey, that guy who just said it's okay, someone talk to him, please. Also, store your keys in a proper vault, like the Vault Project or Amazon's Key Vaults. Isolate your keys so the developers can't extract it, but they can operate on the key without accessing it in their code using proper key isolation. Also, use a well-vetted crypto library like Google Tink or libsodium. This is hard to get right. Here's some cheat sheets from OWASP. We're looking at A4XXE. This is about XML level attacks. This is where I can build a DTD-based XML and say entity XXE system is a system file or a shadow file. So with this attack, I send this XML to your server. It lets me extract a file off your system because of a poorly configured XML parser in your code. Here's other attacks of this category, but the trick is to configure your XML parser, turn off DTDs and external entities. And so this is a well-known attack category. It's a real-world one that attackers use frequently, at least back in 2018. It's still happening. Here's some cheat sheets. We're looking at A5, broken access control. This is a design topic. Like, for example, this query is vulnerable to an access control evasion. Just by changing the number, I can steal people's data. So I'll add an ownership reference. The owner is a user ID from session. The point is, I want more time on this. So for now, code to a feature name, don't code to a role, and consider advanced access control standards like attribute-based access control. And again, here's a NIST standard on modern access control. It's design heavy. Work hard to get this right up front. And a quick note on A6 configuration. A lot of configuration drives security now. Like my whole infrastructure, it's a YAML file, right? So if you can't verify a config file, assume it's not secure. Go out of your way to use automation or an expert to review your stuff for security, your configuration stuff for security. A7 cross-site scripting, it's when the attacker can inject script into your website through one of your actual web features. There's reflective and stored XSS, where we're literally implanting content in your website that contains JavaScript. So when another user looks at that content, they're executing JavaScript from the attacker. The attacker, when doing cross-site scripting or content injection, the real name, they can steal some data, deface the website, and to stop it is painfully difficult. It's so easy to get cross-site scripting wrong. The saving grace are new standards like content security policy, as well as trusted types. But as of right now, learning a framework and doing XSS defense is painfully difficult. There's several different cheat sheets on this topic. Go study. A8, insecure deserialization. When you're automatically deserializing binary data on the server that comes from an untrusted source, the attacker can modify that binary, add an operating system command capability to that binary. So when it's deserialized, the attacker is executing operating system commands on your server. Back in 2017, when this was a big problem, most live defenses did not work. This paper debunked how to stop deserialization. And by the way, all the third-party libraries of this era are vulnerable, like the XML and JSON libraries. I hope you update those. If you have really old JSON or XML libraries, they're vulnerable to deserialization attacks through how XML parsers and JSON parsers work. This is a hard topic. Here's the Oracle Secure Coding Guide on this, and some other defense guides on how to stop this problem. It's hard. A9, using known vulnerable components. Last time I built a big piece of software, these are some third-party libraries I was using, all vulnerable to critical security problems. The whole Equifax issue was because of third-party library security. So we want to use tools to scan our development environments looking for known insecure third-party libraries. The big flagship project from OWASP is OWASP Dependency Check. I highly recommend you use it every day when you're developing software. There's .NET specific tools. There's JavaScript specific tools like retire.js and NPM audit. And so please, at the very least, scan your development environment for third-party library insecurity. At the very most, keep everything up to date at all times. Here's my last topic, logging and monitoring. We need logging and monitoring for three things: intrusion detection, forensics after an attack, and for law and compliance, right? So log often and log early. And at the very minimum, log all authentication events, all access control failures, and all input validation errors. If that's all you do, then you'll give me enough information to do proper forensics and compliance and similar around security issues. Even better, work with the security team so you actually have a standard around what to log. And here's some additional things to consider for your logging mechanism. That first list is most important for security. Here's a few things not to log, like credit card data and session IDs and privacy-centric data that you don't have permission to be storing. Here's a couple notes on logging from the OWASP Foundation. So yeah, write secure code, folks. Test your software for security all the time. You know what time it is for me? I'm going to the beach. It's been my great pleasure. Please go forth and write secure code. I salute you all. Thank you so much for your time. Bye-bye, everybody.